Schedule 80 PVC is a type of polyvinyl chloride pipe characterized by a thicker wall compared to Schedule 40 PVC. This increased wall thickness directly translates to enhanced mechanical strength and durability. The primary advantage of Schedule 80 PVC lies in its superior resistance to impact, pressure, and temperature variations. This makes it suitable for applications where the conduit is subjected to physical stress or environmental extremes. Schedule 40 PVC, on the other hand, possesses a thinner wall and is generally less robust than Schedule 80 PVC. While Schedule 40 is adequate for many general-purpose electrical installations, it lacks the necessary strength for demanding environments. The National Electrical Code, or NEC, Section 334.15b specifically addresses the protection of non-metallic sheath cable, often referred to as NM cable, which is commonly used in residential and light commercial wiring. When NM cable is exposed to physical damage, the NEC mandates that it be protected by conduit, among other approved methods. The reference to Schedule 80 PVC in this context underscores the code's intent to provide a higher level of protection in situations where the cable is vulnerable. Consider a scenario where an NM cable is run along the surface of an exterior wall. This cable is susceptible to impact from tools, equipment, or even accidental contact. In such cases, Schedule 40 PVC may not offer sufficient protection. If struck with enough force, it could crack or break, leaving the NM cable exposed and creating a potential electrical hazard. Schedule 80 PVC, with its thicker wall, is much more likely to withstand such impacts, safeguarding the cable and preventing damage. The NEC emphasizes safety, and the requirement for Schedule 80 PVC in exposed locations is a direct reflection of this principle. It is not simply a matter of preference, it is a code-mandated measure to ensure the integrity of the electrical system and protect individuals from potential hazards. When interpreting NEC requirements, it is crucial to understand the intent behind the code. In this case, the intent is to provide adequate physical protection for an NM cable in vulnerable locations. Schedule 80 PVC is deemed necessary because it offers a significantly higher level of protection compared to Schedule 40 PVC. Using Schedule 40 PVC in a situation where Schedule 80 is required would be a violation of the NEC and could potentially lead to serious consequences. Now let's delve into some specific aspects of PVC conduit. PVC conduit is available in various sizes, ranging from 1/2 inch to 6 inches in diameter, and even larger sizes for specialized applications. The size of the conduit is determined by the number and size of the conductors that will be installed within it. The NEC provides tables that specify the maximum number of conductors allowed in each size of conduit. These tables take into account the conductor size, insulation type, and the conduit's internal diameter. When selecting PVC conduit, it is essential to consider not only the size but also the temperature rating. PVC conduit is typically rated for use in temperatures up to 75 degrees Celsius or 167 degrees Fahrenheit. However, some specialized PVC conduits are available with higher temperature ratings. It is crucial to ensure that the conduit's temperature rating is suitable for the environment in which it will be installed. For instance, if the conduit is exposed to direct sunlight in a hot climate, it may be necessary to use a conduit with a higher temperature rating to prevent it from deforming or becoming brittle. Another important consideration when working with PVC conduit is the method of joining the sections together. PVC conduit is typically joined using solvent cement, also known as PVC glue. The solvent cement chemically melts the surfaces of the PVC, creating a strong and permanent bond. It is essential to use the correct type of solvent cement for the specific type of PVC conduit being used. There are different types of solvent cement for Schedule 40 and Schedule 80 PVC. Furthermore, it is crucial to follow the manufacturer's instructions carefully when applying the solvent cement. This includes properly cleaning and priming the surfaces to be joined and allowing the cement to cure for the recommended time. A properly joined PVC conduit can separate, creating a potential hazard. In addition to solvent cement, PVC conduit can also be joined using threaded fittings. Threaded fittings provide a mechanical connection that is strong and reliable. However, it is important to use Teflon tape or pipe dope on the threads to ensure a watertight seal. Over-tightening threaded fittings can damage the PVC, so it is essential to tighten them only to the point where they are snug. When installing PVC conduit, it is important to support it properly. The NEC specifies the maximum spacing between supports for PVC conduit. The spacing varies depending on the size of the conduit and the environment in which it is installed. In general, smaller conduit requires closer support than larger conduit. Furthermore, conduit installed in areas subject to vibration or physical stress will require more frequent support. Proper support prevents the conduit from sagging or becoming damaged. PVC conduit is also available in various colors. While the color of the conduit does not affect its electrical properties, it can be useful for identification purposes. For instance, blue conduit is often used for underground installations, while gray conduit is commonly used for general-purpose applications. The NEC does not mandate specific colors for PVC conduit, but local codes or project specifications may require the use of certain colors. When bending PVC conduit, it is important to use a conduit bender designed specifically for PVC. Attempting to bend PVC conduit without a proper bender can result in kinks or cracks. PVC conduit benders typically use heat to soften the PVC, making it easier to bend. The heat can be applied using a hot box or a heat gun. It is important to follow the manufacturer's instructions carefully when bending PVC conduit. Overheating the PVC can cause it to become brittle, while underheating it can make it difficult to bend. Once the PVC is heated to the proper temperature, it can be bent to the desired angle using the conduit bender. It is important to maintain a smooth and consistent bend to prevent kinks or flat spots. After the bend is complete, the PVC should be allowed to cool before being handled. Now, let's consider some additional factors related to the use of Schedule 80 PVC. While Schedule 80 PVC provides superior physical protection, it is also more expensive than Schedule 40 PVC. Therefore, it is important to carefully assess the specific requirements of the installation to determine whether Schedule 80 is truly necessary. In some cases, alternative methods of protection, such as using rigid metal conduit or encasing the cable in concrete, may be more cost-effective. Furthermore, Schedule 80 PVC has a slightly smaller internal diameter than Schedule 40 PVC for the same nominal size. This means that it may be necessary to use a larger size of Schedule 80 conduit to accommodate the same number of conductors. The difference in internal diameter is typically not significant, but it is something to be aware of when planning an installation. When installing PVC conduit in direct sunlight, it is important to use conduit that is rated for sunlight resistance. Sunlight can degrade PVC over time, causing it to become brittle and crack. Sunlight-resistant PVC conduit is formulated with additives that protect it from the harmful effects of ultraviolet radiation. These additives help to prolong the life of the conduit and prevent it from deteriorating prematurely. In addition to sunlight resistance, it is also important to consider the chemical resistance of PVC conduit. PVC is generally resistant to a wide range of chemicals, but some chemicals can attack and degrade it. If the conduit is to be installed in an environment where it will be exposed to chemicals, it is important to select a conduit that is specifically rated for chemical resistance. The manufacturer's datasheets will provide information on the chemical resistance of different types of PVC conduit. When running PVC conduit underground, it is important to bury it at the proper depth. The NEC specifies the minimum burial depth for PVC conduit based on the voltage of the conductors it contains and the type of location. In general, conduit carrying higher voltage conductors must be buried deeper than conduit carrying lower voltage conductors. Furthermore, conduit installed under roadways or driveways must be buried deeper than conduit installed in other areas. The proper burial depth protects the conduit from damage from vehicular traffic and other external forces. In addition to burial depth, it is also important to consider the type of backfill material used when burying PVC conduit. The backfill material should be free of sharp rocks or debris that could damage the conduit. Sand or fine gravel are ideal backfill materials. It is also important to compact the backfill material properly to prevent settling. Settling can cause the conduit to sag or become damaged. When terminating PVC conduit at an enclosure, it is important to use a proper conduit fitting. Conduit fittings provide a secure and watertight connection between the conduit and the enclosure. There are various types of conduit fittings available, including connectors, couplings, and adapters. The type of fitting used will depend on the specific application. It is important to select a fitting that is compatible with the type of conduit being used and that provides a proper seal. When installing conduit fittings, it is important to tighten them properly. Over-tightening fittings can damage the conduit or enclosure, while under-tightening them can result in a loose connection. It is important to follow the manufacturer's instructions carefully when installing conduit fittings. In summary, the choice between Schedule 80 and Schedule 40 PVC depends on the specific application and the level of physical protection required. Schedule 80 PVC is the preferred choice for exposed locations where the conduit is subject to physical damage. It is more expensive than Schedule 40 PVC, but it provides a significantly higher level of protection. When working with PVC conduit, it is important to consider the size, temperature rating, chemical resistance, and burial depth. It is also important to use proper installation techniques, including solvent cementing, threading, bending, and supporting. By following these guidelines, you can ensure that PVC conduit is installed safely and effectively. Furthermore, always consult the latest edition of the National Electrical Code, or NEC, and local codes to ensure compliance with all applicable regulations. The NEC is a comprehensive set of standards that covers all aspects of electrical installations. It is updated every 3 years to reflect the latest technological advancement and safety practices. Familiarizing yourself with the NEC is essential for anyone involved in electrical work. The NEC provides detailed information on conductor sizing, conduit fill, overcurrent protection, grounding, and many other topics. It also includes specific requirements for different types of installations, such as residential, commercial, and industrial. In addition to the NEC, local codes may also impose additional requirements. Local codes are often based on the NEC, but they may be modified to address specific local conditions. It is important to check with the local electrical inspector to determine which codes are in effect in your area. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself from injury. Always energize circuits before working on them and use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and effectively. They can also ensure that the installation complies with all applicable codes and regulations. Remember safety first, and always consult the NEC and local codes before beginning any electrical project. This will help to ensure that the installation is safe, reliable, and compliant with all applicable regulations.